Hello everyone, in this module we are going to learn the working of linear algebra module. So these are the following topics we are going to discuss in this video. Firstly, we will discuss what is linear algebra in Python, and then we will discuss the functions which are required for linear algebra. Now let us understand what is linear algebra in Python. So basically linear algebra can be defined as a branch of mathematics that deals with the study of linear functions in vector space or matrices. So it is the most important part of the data science and machine learning, and the data is denoted by the linear equations such as this one. Now we will discuss what is linear equation. Basically a linear equation is a straight line that we have mentioned in. So it is a collection of two or more equations which contains same variable. So this is the system of linear equation, and the goal of solving this equation is to find out the values of unknown variables. So these are the common functions to operate the different algebraic calculations on vectors and matrices. Now let us briefly understand about these functions on NumPy array. Before using these functions on NumPy array, let us understand what exactly is matrix multiplication in Python. So this is the input array and it is considered as a 2 by 2 matrix. Now we have to multiply these two matrices. So generally it can be multiplied by first row and the first column. As you can see that the first row element, that is 12, is going to multiply with the first column first element, and same in the case of first row second element and the first column second element. So we have to add it and store in the result as output. Same in the case of second row and second column, you can multiply it. Now after multiplication of two matrices, we will discuss about this function based on linear algebra. Now we will discuss our first function, that is NumPy dot function. So basically this function is used to calculate the dot product of two NumPy arrays, and this function takes two NumPy arrays as an argument. So for example, you have two NumPy arrays, that is x and y, and input array has 4 values. Now when we calculate the dot product of input arrays, firstly we will multiply the first value of x by the first value of y. So here is the syntax of NumPy dot function, and within this function there are only 3 parameters. The first one parameter is a. This parameter specifies the first input array, and it can be any scalar value or array type object. The second one parameter is b. This parameter specifies the second input array for dot product method, and the last parameter is out. By default it takes none value and it specifies the output of the array where the result will be stored. Now we will see an example of a NumPy dot function by creating one-dimensional array. So here I have taken an example, and in this example I have created two NumPy arrays in the form of one-dimensional array and computed their dot product by using NumPy dot function. So it takes the product of the pairwise elements of the input array and then adds them together. So we have passed the input arrays as an argument in NumPy dot function. So after executing this code, the output comes the multiplication of two arrays 1 3 0 3 3. So after understanding the NumPy dot function, we will discuss about the NumPy v dot function. This function is used to get the dot product of two given matrices, and it also handles multi-dimensional arrays. So it will check the condition. If the first parameter is complex, then its conjugate is used for calculation. So this function consists of two parameters. The first one is a. This parameter indicates the vector a, and if it is complex in nature, then its conjugate is used for calculation. And the second parameter is b, and it is similar as a vector a. So this method returns the dot product of the input vectors, and the output can be in the form of complex, float, or an integer type. Now let us see an example of how to use the NumPy v dot function with an integer value array as an argument. So in this example we have taken two vectors by using np dot array functions, and we have passed integer values of shape 2 by 2 as an argument. Next we use the NumPy v dot function and assign these two vectors as a parameter. Now the v dot product is calculated and it will store the output into a result variable. So after executing this code, the output comes, the multiplication of two vectors is 5 7 2 9. Now we will discuss our next function, that is NumPy dot inner. So basically this function is available in the NumPy package module, and it will return the inner product of two input arrays, and the arrays can be a one-dimensional array or multi-dimensional array. While in the case of higher dimension, it will return the sum product over the last axis. So again, this function takes two parameters, and the first and second parameter indicates the input arrays, and if array1 and array2 are non-scalars like array object, then their last dimension must match. Now let us discuss the numpy.inner function in the case of the one-dimensional array. In this example, we have taken two input arrays in the form of one-dimensional array named as sample input and the random numbers. Next, we use the np.inner function and pass the input arrays to it. And once you will execute this code, the output displays the inner product of two input arrays, and the result will return in the scalar form. Now if you want to return the outer product of two input arrays, then we are going to use the np.outer function. So basically this function is used to calculate the outer products of two input arrays, and the input array will be a single or multi-dimensional. So in this example, we have taken two input arrays by using np.array function. Now we have applied the np.outer function and assign both the input arrays in it. After executing this code, the output comes calculating the outer product of two input arrays. So here we will understand the concept of multiplications of two matrices by using the numpy.matmul function. So this function is available in the NumPy package module, and it will return the matrix product of two input arrays. In simple words, we can say that matrix multiplication means when we multiply a matrix with another matrix. If the dimension is greater than 2, then it is treated as a stack of matrices. So this function takes mainly two parameters, and it will return the matrix product of two given arrays. The first one parameter indicates first input array, and the second one is x2 that indicates the second input array. Now let us see an example of how to use the np.matmul function with a two-dimensional array as an argument. So in this example, we have created a two-dimensional array by using np.array function, and inside this function we have passed a numeric integer values as an argument. Next, we have used the np.matmul function for displaying the matrix product of both the input arrays. For this, we have assigned both input arrays within this function. So after executing this code, the output comes the matrix multiplications of both input arrays. Now we will understand our next function, that is NumPy determinant. So basically this function is used to get the determinant value of the given array. In simple words, it is calculated from the diagonal elements of a square matrix. As you can see the diagram, we have a matrix that is 2 by 2 shape. Now we have to find the determinant of given matrix. So to do this, we have take an input as a matrix and multiply each opposite elements and subtract it. So as you can see that minus 30 is the determinant of given input matrix. So remember one thing, this function takes only one parameter, and that represents the input array on which the operations needs to be applied, and it will return the determinant of the given array. Now let us understand how to use the NumPy determinant function in Python. So in this example, we have created a 2 by 2 matrices by using np.array function. Next, we use the numpy.linearalgebra.determinant function, and within this function we have passed an input array as an argument and calculated the determinant manually. So after executing this code, the output comes the determinant of a matrix that is minus 1602. Now we will understand our next function that comes under the linear algebra, and the function name is numpy.linearalgebra.solve. So this function is used to solve a linear equation, and the equation will be ax is equal to b, where a and b are input matrices, and this method is used to find the solution of a linear equation. Now let us see how a system of the linear equation can be used to solve in an array. Suppose a retailer sold 50 apples and 14 grapes in one day for an amount of $400, and next day he will sold 12 apples and 17 grapes for $750. Now we can solve this problem with a system of two linear equations. System of linear equation can be used to solve in an array, that is 50a plus 14b equal to 400, and the next equation is 12a plus 17b equal to 750. Now the solution to this equation is by using numpy.linearalgebra.solve function. So as per the equation, we have created two arrays, and the arrays are created by using np.array function, and within this function we have assigned those equations values as an argument. After that we have used the numpy.linearalgebra.solve function, and within this function we have assigned both the equation as a equation 1 and the equation 2 as a parameter. So after executing this code, the output comes the linear equation values. Now we will understand our next function, that is numpy inverse. So basically this function is used to calculate the inverse of a matrix. In simple words, the inverse of the matrix is when we multiply the given matrix with the identity matrix. Suppose we have an equation ax is equal to b. Now we have multiplied both sides by A inverse. The equation will be A inverse ax equals to A inverse b. So after multiplying this, the equation will be x equal to A inverse b, because A inverse dot A equals to 1. So in this new equation, A inverse will be the inverse of a matrix. So again, this function takes only one parameter and it represents the input array. Now let us understand how to use the numpy inverse function in Python. So in this example, first we have created an array by using np.array function. After that we have used the numpy.linearalgebra.inverse function, and within this function we have assigned the given input array as an argument. So after executing this code, the output comes the inverse matrix. So with this we have completed the working of linear algebra module.